Hey everybody, welcome back. Today I'm going to start talking about something called an inverse function. I'm not sure how many videos it'll take to finish this series. Probably several because I want to do some good examples. Some inverses are harder to find than others. Alright, so an inverse function is best thought of to me as a function that undoes the operation of another function. Okay, so I'm going to show you a real quick example of this idea, then I'll get to the lesson notes, okay? So to make my point here, I'm going to draw something, and I just wanted to lay out the idea of what an inverse function is. Okay, so I don't know, y'all remember mappings from way back. Probably maybe hadn't seen them since Math 1. All right, and let's imagine a function that does something for us, and we'll make it a simple function like this, a squaring function. All right. Now this function, by its strict definition, wouldn't have an inverse, but we can fix that, and I'm not going to focus on that for this example, but I want to show you how it works. So if we put 2 into our function, all right, we're going to use 2. F squares a 2, right, and sends it over here and makes it a 4. We all agree 2 squared is 4. That's what F did, right? F inverse has to undo that. F inverse undoes it and sends it back. Now we know to undo the squaring of a 2, we need to take the square root of that number. So think about this. To make this 4 come back to a 2, that takes the inverse function. And they use this notation, F inverse. That does not mean F to the -1 power. They're not the same thing. It means F inverse. Okay? So F inverse of x is the square root of x. And you can see that it works. If you put a 3 in, 3 gets squared, becomes a 9. 9 comes back to a 3. That's what an inverse function does. All right. Now, with that example, I'll start off on the notes and just explain them to you. And I thought it'd be good just to show you what one does in just plain terms. And then we'll go to work on this formal definition stuff, okay? Which it gets a little bit messy looking, and I'll try to explain it the best I can. Let's see here. That would be located right here in lesson notes 1.4. All right. Okay, so the very first thing that has to be true here for us to find an inverse function, and that's going to be our job in this section, is the function has to be one-to-one. All right. The definition of a one-to-one function. A function with a domain A is called one-to-one if no 2 elements of A have the same image. All right, so what that means is for any input that's different, you can't have the same output. They can't be. All right, and we could show a mapping, and you know what, let's just do it that way. Let me show another mapping to show you how this is a problem for us. Now I know that I just used x squared to show you how to find an inverse, but I told you it really needed to be corrected, and I'll have to address that later. Just imagine the squaring function again. All right, it will square a 2 to go to a 4, right? We just saw that, but it squares a -2, and it also goes to a 4. In other words, these 2 values are different and they have the same image. That's not permitted. So this is not one-to-one. It's not one-to-one. Now, can that be corrected? Yes. You just explicitly restrict the domain, and now it is one-to-one. And that's what they'll do. And that's what we should have wrote in our first example a minute ago. I should have wrote, but I didn't. I didn't want to make it more confusing. I'll get to this in more detail later. So let's keep moving here. So we know what it means to be one-to-one, hopefully. It just means that you can't have the same image or the same output for 2 different values of x, okay? Now, one way to test this, if it is one-to-one, is through a graph. If you just imagine the graph of x squared, you would realize that it's a parabola, and it would not pass what they call a horizontal line test. So one way to test this, a function is one-to-one if and only if no horizontal line intersects its graph more than once. All right, so here's the little image I found that demonstrates this. This looks like possibly an exponential function or something like that, and it passes a horizontal line test. Because you remember back in the day we used to talk about the vertical line test testing, if something was a function or not. Well, to test for it to be one-to-one, it needs to pass a horizontal line test. This fails the horizontal line test. It is not one-to-one. And just real quick, to illustrate that point one more time, the example that we just used, we had y equals x squared. Now this is a really crude, oh, I just screwed that up. It's a really crude example. That was too crude for me, y'all. Sorry. I'm drawing crooked as all get out here, but you know what? We can't help it. Sometimes we just gotta. It's just for a quick illustration. Well, suppose that's x squared, and I know it looks terrible. Obviously fails a horizontal line test. I mean, it just fails in all kinds of ways. Anywhere you draw it, it fails it. Now, when I corrected the domain, it said it could only exist greater than 0. Now it passes. So that's what we're talking about doing. All right, so that's one test that would have to run. Now, definition of an inverse function. Here's the definition in strict terms. Let f be a one-to-one function with domain A and range B. Then its inverse function, here's that notation I told you about, has domain B and range A and is defined by this expression right here. And I don't want you to get carried away with that. That looks very confusing probably. What's important here is you see how the range and domains are flipped. All right, the function has domain A, range B. The inverse has domain B, range A. In other words, the range of the function is the domain of its inverse. That will be something that is important in another video. So this right here is important. And I put this graphic in here of a little mapping so you can see what happens. X goes into F, it sends it to Y, or its output values. F inverse has to send it back. So as we find these inverse functions and we think we have one, that's a little test we could run. Now there's a formal test using a composite function that I'm not sure I want to include or not. I mean, we may use it, we may not. I don't know. We'll just see how sticky this gets. Okay. So that's going to be it for this video. I think I've laid out what an inverse function is. This is like an intro. We'll call this Intro to Inverse Functions. And make sure you take a notes on this. Maybe draw the mapping for sure. And this right here is important. Looking for something to be one-to-one would be important too. If it's not, it could be corrected like you saw me do. Not everything can be, but anyway. Thanks for watching, and I'll see you in the next part.